Hi guys, so today I'll be explaining the chemistry quiz for term 1 week 2. The equations that we're gonna need for this exam are Q equal M times C times temperature final minus temperature initial, or delta T. Next one, delta H is equal to Q over N. This is if it is endothermic. And then we have delta H is equal to negative Q over N. This is if it is exothermic. And then finally we have the enthalpy. It is the heat of reactants minus heat of product. So these are the 1, 2, 3, 4 equations that we need for this exam. Now, let us start. The temperature of 280 grams of water, this is a mass, was noted to be 32 degrees after dissolving 8 grams of NaOH in a calorimeter. So after dissolving, so this is our final temperature. It takes 4 joules. This is what our C, this is the amount of energy needed to change the temperature of 1 gram by 1 degree Celsius. Okay? And finally, we have our Q. Q is either the heat absorbed or the heat released. What are they asking for though? They're asking for the initial temperature. So that means we're going to use this equation. Q equal M times C times temperature final minus temperature initial. We have our Q, as we said, 6720. It's equal to our mass, 280, multiplied by our C, which is 4, multiplied by final temperature, 32, minus initial temperature. So now we have this equation, we can solve it. We're going to bring this to the other side. We're going to have 6720 over 280 times 4. It's going to be 6. So now what do we have? We have 6 is equal to 32 minus temperature initial. So if we bring 32 to the other side, now what do we have? We have negative 26 is equal to negative temperature initial. We put positive here because the minus cancel each other. So we're going to have 26 is our initial temperature. Question number 2. Which of the following are examples of endothermic processes? Endothermic processes are the ones that take in heat. So if you're heating something, then of course it's going to take in heat. That's why heating carbon with water vapor to form hydrogen gas is endothermic. Cooling water vapor, you're making it from a gas to a liquid. So then you are reducing the speed of the molecule, so you're reducing the heat. So it is not a endothermic process. Melting an ice cube, however, you are giving heat to the ice cube. You're changing it from a solid to a liquid. So you are giving more heat for the particles to move faster. So yes, it will take in the energy, so it is endothermic. And if they tell you just reacting, you will not know. So as we said, the reacting, it will not be considered because we don't know if it's taking in heat or releasing heat. Question number 3. So now, question number 3. A group of students were asked to measure the amount of heat generated during a reaction. If you ever have to measure the amount of heat during a reaction, you use a calorimeter or a bomb calorimeter. Okay? Now, what do they need to measure again? The amount of heat. So, the change in temperature. They should measure the change in temperature because it's the amount of heat that they got. So the change in temperature, you measure it inside a bomb calorimeter in which the volume is stable. The volume has to be stable. The pressure, it can change, okay, but the volume has to stay constant. Question number 4. Calculate the enthalpy change. As we said before, the enthalpy change, it is what? The heat of the reactants minus the product. So first of all, let us find the heat of the reactants. We have 1 double C bond plus 4 CH bonds plus 1 single Cl bond. So what does it mean? If we put it on our calculators but with the values, we're gonna have 1 times 602 plus 4 times 413 plus 1 times 240. So on our calculators, if we do it, 602 plus 4 times 413 plus 240, we are gonna get 2494. So for here, our value was 2494. Let's find here the value. We have 1 CC bond, we have 4 CH bonds, and we have 2 CCl bonds. So that means we're going to have 1 times 346 plus 4 times 413 plus 2 times the CCl, which is 327. So we're going to have 346 plus 4 times 413 plus 2 times 327. We're going to get 2652. So that means we're going to have 2494 minus 2652. It's going to give us negative 158. But they require it in what? 4 significant figures. So minus 158.0. Don't forget the 0.0. Number 5. Calorimetry is the measurement of reaction heat. Please memorize that. Here, the change in temperature of a particular calorimeter and its water contains 1 degree requiring, okay. What do they require? Just by scanning, you can know that they require delta H. And we said for delta H, we have 2 equations. Delta H equals what? The Q over N if it's endo, and delta H equals negative Q over N if it is exo. Okay, so here we need to figure out whether it's endothermic or exothermic. We have the complete combustion, and we know combustion is exothermic, and it causes a temperature rise. Anytime you see temperature rise, that means it is exothermic. So the equation we're going to use is delta H equals negative Q over N. So if we're going to replace, or we're going to expand the equation even more, we know that negative Q usually is M times C times delta T. But in this case, when they're talking about negative Q over N, and they're talking about a gas, okay? Whenever they're talking about a gas or a liquid, we only use Q as C times delta T without the mass. So without the mass. We're gonna use the mass for what? To find the number of moles. So we're gonna have 7 over the molar mass, which is 28 in this case. So again, I'm gonna do it. I'm gonna explain it one more time. We are gonna use delta H equals negative Q over N. If they're talking about a gas or a liquid, for the Q, we're gonna do only the C times delta T without the mass. And for the number of moles, it's mass over molar mass. So we're gonna replace it now. We have the C, which is 5 kilojoules, multiplied by the change in temperature, which was 5. We don't forget the negative because it's negative. And then we do 7 grams over 28. So we're going to have negative 25 over 0.25. So it gives us what? Negative 100 kilojoules per mole. Negative 100 kilojoules per mole is our answer. Number 7. Find the heat of combustion of ethene. Okay, here they're asking for delta H of combustion. Remember, we said the only time we do reactants minus product is if they ask for the enthalpy change. Here they're asking for what? The combustion of ethene. So we are gonna do products minus reactants. One more thing, when they're asking for the heat of combustion or the heat of formation, okay, we do not consider any elements. So O2, H2, N2, anything that has one single letter or like a big and a small one, anything that is one element. For example, O2, we do not cancel it. It will not have a heat, okay, in this case. So let us find the heat of the reactants. We have O2, so we cancel it, and we take only the heat of C2H2. That means the reactant's heat is 228. What about the product's heat? We have 2 times CO2, negative 394, plus the H2O, which is negative 286. So we're gonna do then products minus reactants. So 2 times negative 394, okay, plus minus 286, okay? This is by itself. We are gonna get what? 2 times minus 394 plus minus 286. We're gonna get negative 1074. And then we're gonna subtract it from what? From 228. So minus 228, we're gonna get negative 1302. This is our final answer. So the final answer is negative 1302. The final question, number 8. It takes 0.71 joules to raise the temperature of 1 gram of graphite by 1 degrees Celsius. Calculate the energy required for each of the following. So they're asking for what? For Q. We know the equation for Q is equal to C times M times delta T. So let us find our C. We have 1 gram here and 1 degree Celsius. So directly, this is our C. What is C, by the way? C is the amount of energy needed to change the temperature in 1 gram and 1 degree Celsius. So we have this as our C. Then they will give us what? The weight, the mass, the mass and the change in temperature. So we're gonna use Q equal M times C times delta T for this one. What will we get? We're gonna have Q is equal to mass of 1 mole. This is of graphite, which is carbon. The mass of 1 mole of carbon is 12, okay? Multiplied by what? By our C, which is 0.71, times 2. So 12 times 0.71 times 2, we are gonna get what? 17.04, but they needed the 2 significant figures, so only 17. How about this one? The temperature of, we're also gonna do Q equal M times C times V. Our M is 24, our C is 0.71, and our V, our delta T, not our V, my bad, our delta T is 5. So we're gonna have 24 times 0.71 times 5, which is 85.2, but they need only to 2 significant, so we're gonna take only 85. And last but not least, we have this one. We're gonna do Q equal M times C times delta T. We have the M 36, our C 0.71, and we have our T. What is the difference here? We have 296 and 294. 296 minus 294 is 2. So this is the change in temperature. So it is gonna be 2. So it's gonna be 36 times 0.71 times 2. We're gonna have 51.12. We only needed the 2 significant figures, so it is gonna be 51 joules. So let's submit and see. Alright guys, thank you for watching this video and I hope you understood and have a nice day.